Get ready for a cosmic phenomenon that could completely reshape the way we understand the universe. One of the most massive and well-known stars in our galaxy, Betelgeuse, a towering red supergiant located on the edge of the Orion constellation, is showing signs of profound and possibly ominous change. Astronomers using the Advanced James Webb Space Telescope have detected unusual activity coming from this colossal star, stirring both fascination and deep concern in the scientific community. Notably, astrophysicist Brian has expressed serious caution, leading many to ask, are we on the verge of witnessing a stellar event so immense and destructive that it could permanently alter the night sky? Betelgeuse has always captured attention, not only due to its striking red glow, but because of its sheer size and behavior. Tucked into the shoulder of Orion, this giant star is nearing the end of its life. It's about 764 times the size of our Sun. So immense that if it were placed in our solar system, its surface would stretch far beyond the orbit of Mars, completely engulfing Mercury, Venus, Earth, and even the red planet itself. This staggering scale highlights the dramatic and powerful forces at work within it. More than just enormous, Betelgeuse is in a critical stage of its life known as the red supergiant phase. After billions of years fusing hydrogen into helium, it is now burning through heavier elements and slowly losing mass. Despite being around 8 to 8.5 million years old, a relatively young age in human terms, it's ancient by stellar standards. Massive stars like Betelgeuse live fast and die young, and its current state signals that the end may be near. One of the star's defining traits is its reddish color, which comes from its surface temperature, around 3,500 Kelvin, significantly cooler than the Sun's 5,500 Kelvin. This cooler temperature gives it that signature hue and provides astronomers with key information about its internal changes. Historical records suggest that Betelgeuse hasn't always appeared red. Ancient Roman and Chinese texts describe it as yellow some 2,000 years ago, while Arabic astronomers in the 9th century noted its redder appearance. This shift in color over time is more than an intriguing historical note. It's a marker of the star's ongoing evolution. Betelgeuse is also known for its fluctuating brightness. It's classified as a semi-regular variable star, meaning its brightness changes over a cycle of about 400 days, with longer fluctuations happening over a 5-year period. While this behavior has been observed for centuries, the star has sometimes shown unexpected changes that don't fit known patterns. One of the most dramatic examples occurred in late 2019 during an event now called the Great Dimming. Over the course of a few months, Betelgeuse's brightness decreased so noticeably that even casual stargazers could detect it, despite city light pollution. At its lowest point in February 2020, it was dimming at a rate of 0.01 magnitudes per day. But there's a critical factor we must keep in mind. The light we see from Betelgeuse doesn't show us its current state. It shows us how the star looked about 725 years ago, because that's how long its light takes to reach Earth. This means any changes we observe now actually happened centuries ago. If Betelgeuse were to explode as a supernova, we wouldn't know until long after the event had already occurred. This delay, caused by the immense distance, presents a major challenge for astronomers who must interpret ancient signals to understand a star's present and predict its future. Despite this cosmic time lag, astronomers have continued to investigate the causes behind the star's recent dimming. A research team led by Andrea Dupree at the Center for Astrophysics at Harvard and the Smithsonian used the Hubble Space Telescope to study the outer atmosphere of Betelgeuse during the dimming episode. They discovered that the star was shedding material at astonishing speeds, about 200,000 times more than the solar wind from our Sun. This material formed a dense dust cloud that partially blocked Betelgeuse's light, accounting for the sharp drop in brightness. The scale of this mass ejection was staggering. It's estimated to be roughly 400 billion times greater than a typical coronal mass ejection from the Sun. Theories suggest that this material was likely a burst of superheated plasma from a giant convection cell on the star's surface. It traveled outward and cooled. It condensed into dust, creating a massive cloud that temporarily obscured the star. This dramatic release of matter has led scientists to wonder whether such an event might signal the star's impending death and the lead-up to a supernova. Several explanations have been proposed for the dimming. One idea is that Betelgeuse is entering a late phase in its life cycle, moving closer to a supernova. Another suggests that the dust it expelled simply blocked our view. A third theory points to structural changes in the star's outer layers, which could affect how bright it appears. While no single explanation has been confirmed, the findings point to dramatic internal changes and raise the possibility that Betelgeuse might explode sooner rather than later. The big mystery remains. When will Betelgeuse go supernova? Some scientists speculate it could happen within a few decades, while others believe it might take up to 100,000 years. Whatever the timeline, the evidence suggests that Betelgeuse is approaching the end of its life. And if it does explode while we're alive to see it, the result would be nothing short of spectacular. The star would collapse in on itself in what's known as a core collapse supernova, an explosion so powerful it would release more energy in a few weeks than the Sun will over its entire 10 billion-year lifetime. During this event, Betelgeuse would briefly become as bright as the full moon, visible in the daytime sky. Despite how close it is in astronomical terms, Earth would remain unharmed by the explosion's radiation. Still, such an event would be a once-in-a-lifetime opportunity for scientists to observe a supernova up close. The data gathered could help answer fundamental questions about how stars live and die, how elements are formed, and how galaxies evolve. As we continue to observe Betelgeuse and study its every flicker and pulse, we are reminded of the ever-changing nature of the cosmos. What may look like a steady light in the sky could, in truth, be a ticking time bomb, a dying star preparing for its final fiery act. Whether the explosion comes in our lifetime or long after, one thing is certain. The universe is in motion, and Betelgeuse stands as a glowing symbol of the dramatic and powerful transformations unfolding above us.